Have everybody joined? Hello, am I audible?
Yes, sir.
Anybody more to join this class?
Yes, sir. A few of them are yet to join.
Okay. So till then, do you have any doubt that we can discuss prior to that initiation of the class? Any one
No,
of you,
sir.
any doubt? So you have done till the derivation of this magnetic field due to the circular current carrying conductor now.
Yes, sir.
Okay, so today we'll be solving some questions based on this. So if you have any doubt, you can just poke me out. Otherwise, we'll be starting with the questions.
Okay, sir.
Just let me know when all of you join. So I guess we shall start by now.
Yes, sir. We can start.
Okay. So right, we'll be starting with the questions. This is the first question that we have been they're seeing in the screen. Okay. Like I am still like recognizing that you don't have any doubt over this topic, and we'll be just solving questions in order to gain the strengthen over this concept. Right?
Yes, sir.
Okay. Right. So the first question says that the plane of a circular coil is horizontal. Okay, it has 10 turns, each of radius 8 centimeter, and a current of 2 ampere flows through it. The current appears to flow clockwise from a point above the coil. Then you have to find the magnitude and direction of the magnetic field at the center of the coil due to the current. So you try this question first. and then I'd like to answer it at the other side if you solve it. Otherwise, I'll be solving it if you're not able to solve this. Okay?
Okay, sir.
Why others are not responding? Netra, Neha, Adarshini, Namrata, Vaishnavi, Laya. Oh, Laya was responding. Every one of you solve this. Try to solve this. Do anything that you can. Doesn't matter that you're getting to the correct answer or not. Any answers?
Sir, can we take it like B is equal to nu naught I by 2R?
V is equals to mu naught I by 2R. Okay,
Yeah.
that was good. Because at the center of a current carrying circular coil, the magnetic field is this only. Let us say that this is a coil facing upwards. This is upward facing coil. Okay, the face that you are seeing this, it is upward. From here you are facing it, right? This is the I. I hope so. You understand this. Mind,
Yes.
don't mind. Next thing.
Mm.
So the thing they are saying that we can see there are 10 coils, 10 rounds are there. Okay, radius is 8 centimeter, right? And the current that is flowing is 2 ampere. First you write the data that are given. I is 2 ampere. Okay, radius R is 8 centimeter converted into SI unit 0.08 meters. N is 10. Okay, the current appears to flow clockwise. So when you see it from the above part, you feel it to be clockwise, right? So what will be the direction of the magnetic field? Tell me. Direction of magnetic field?
Inward.
Inwards. Very good. So what you do, you just turn your fingers around the like current and see the direction of your thumb. Okay, if you do that, you'll get the direction of the magnetic field. Everyone understood? Yes or no? Turn your fingers and put the thumb downwards. Everyone understood?
Yes, sir.
Okay, so you can see that the magnetic field is going inside like this. Like this, right? Now, the formula that Laya said that B is equals to mu naught, we can say that N I by 2R, right? It is a special case of the derivation that you have done, that you derived for some axial distance, but when you put that axial distance x to be 0, you get it to be at center, the magnetic field, and that is correct. When you put it, what did you get as the value? Magnetic field?
I didn't substitute it yet. Sir.
Do it. because you should have the habit of calculation also. In the exams, you'll be just you will want to get rid of such calculations. That will be so huge. So you should have that habit. You won't be getting any calculator there. Even in those JEE and NEET competitive exams, they go for these calculations. These much calculations they give. And even if you did it correctly and you got the silly mistake, that is the calculation error, so you won't get anything. Try to do it and do it fast, as fast as you can.
Sir,
Yeah, how much you're getting?
so 1.57 into 10 to the power minus 4.
10 to the power minus
4.
4. Okay, this is said by Adarshini. Any more answers?
15.7 into 10 to the power minus 5.
Minus
Yeah, same
5.
answer. Yeah.
Same answer. Laya. Okay, this is correct. Both are correct. But the you must have studied class 11th orders and orders of was that topic in units and dimensions? Order of magnitude. Have you studied this? Any physical representation, any answer that we write in physics has a particular representation criteria. So it should follow this: a dot b raised to the power c. And this a dot b should be less than 5 and greater than 0.5. Okay. This is how you have to represent any answer. So, Laya, your answer, the representation is wrong. Answer is correct. The representation is wrong because it is exceeding 5. This answer is correct. Both are correct. Marks will be given to both. But generally in JEE or NEET, the options will be like the first one. Okay, so try to represent things like that. If you will be creating this as a habit for yourself, so that will be benefit for you. Right?
Okay, sir.
Everybody, shall we move on to the next question? Any doubt? You're not saying, Netra, Neha.
No doubt.
Okay, good, good. Okay, so now we'll be moving on to the next question. This is the next question. Next question says that in a Bohr model of hydrogen atom, an electron revolves around the nucleus in a circular orbit of radius that is given at a frequency that is also given. What is the magnetic field set up at the center of the orbit? One formula in this particular question is related with your current. If you get that, you can solve this question. Try to think that. Pressurize your brain. For any question, if you go in an ordered way now, you'll be able to answer anything. Okay, ordered way says that first what you have to write the data as given. Then you have to write what is required. Then you should write what are the formulas that you know for that particular thing which is required. And then you think about that. From where should I get this data? If this is missing, how can I calculate this? Is there any other formula? So go like that. Done? We're taking lots of time. Okay, now see. First of all, you tell me what the datas are given. Am I like I have been asked to calculate the magnetic field. So magnetic field, what formula should you use? Tell me what you have thought of using.
Mu naught I by 2R.
Okay, same formula, mu naught Ni by 2R,
Yeah.
right?
Yes, sir.
Now, what do you require? You require N, you require I, you
I.
require R. Is N given to us?
1 nala. 1.
We'll consider 1 because it is taking single revolution. What is I? Is I given to us?
No, sir.
No, not given. R given to us?
Yes.
So
5.
5.11 into 10 to the power minus 11. Is there
Yes.
any other data given to us? Yeah, frequency is given to us 6.8 into 10 raised to the power 15 hertz. This is given to us. Now see, like if this is given, there must be some use of it, isn't it?
Yes, sir.
And this is not given. So I, from where we can calculate this value of I? That is our question. If we calculate that, this becomes easy. So if you remember, I is nothing but delta Q upon delta T. Agree? Yes or no?
Yes, sir.
Everyone? Fine. Now, what is delta Q? Q is equals to NE upon T. Right?
Yes, sir.
Number of electrons into charge of one electron and divided by time. Agree?
Yes, sir.
So if we take this condition, let us say this is the nucleus and this is the electron revolving around this. So if we are taking at a particular situation, we are taking this cross section at a particular instant. Okay, how many electrons are passing through it in this particular radius? Only one,
Yes, sir.
because that is
1.
a hydrogen atom. That is a hydrogen atom.
Yes, sir.
So n is what? 1. Charge and electron we know, and time interval. Now, what is time interval? That is not given to us. Now see here, can I write 1 by t as frequency? Frequency is nothing but 1 by time period,
Yes, sir.
right?
Yes, sir.
So can't I calculate the I from there? Since my n is 1, so it will be E into nu. Agree?
Yes. Yes, sir.
Now can you put the value and get me the value of magnetic field?
Yes, sir.
Easy? Once you get it, you'll find it easy.
So I is equal to 1.088.
You calculate and get the value of magnetic field. I don't have that value.
Okay, sir.
That would be there, probably. Try to put it there, current
Right.
here,
Yes, sir.
and then get the value of magnetic field.
Okay, sir.
Sir, can we leave the answer in terms of pi?
Why? Will you be getting marks if you leave that and you put the same thing in boards?
I'm
Hmm?
asking.
No. See, you should, that's what I was telling you. You should have the habit. Solve it fullest.
Okay, sir.
Hmm.
So 13.34.
13.34. Considered 13.4 is the exact answer. Who said that?
Sir, Darshini.
Okay, good. So magnetic field, please somebody else also do the same. Are you getting this value?
I got 13.3. Yeah.
Yeah, the exact answer that I have is 13.4. These are considered. These are correct. Understood?
Yes, sir.
Okay. So everyone, any doubt? Vaishnavi, Netra, Neha,
No, sir.
Kalpagesh, Darshini,
No, sir.
Sailakshmi,
No, sir.
Divya. Please respond. Then only I'll understand that you got it. Okay, let us move on to the third question. Are you liking this? All the questions have been framed based on this, your boards and the JE level and NEET also. Okay, considered from there. Now, see here, we have a circle here. Okay, we have a circle here. Current is coming from P. Okay, getting divided into the two parts of the circle, right? And that is the proportional according to the proportionality of resistance. Now tell me, how would you find the proportionality of resistance unless and until it is given? The resistance is not given. Okay, now they converge at C and the whole of the current gets out to Q. Here the resistance is not given. But if we say that total current I is coming and that will be divided into I1 and I2, how will you divide I1 and I2? This is a very good question. Tell me, how would you divide I1 and I2? How I is related to resistance? Directly or inversely?
The inverse.
Inversely proportional. So I is inversely proportional to resistance. Agree, everyone?
Yes, sir.
Okay. Now see here. Let us say that R is what? Rho L by A. Right? Area is this area of cross section of the wire, right? This is area. And area would be same for this particular section, these two sections. So let us say that this is R1 from A to D, or I shall write it like RADC. I'll be writing it RADC, and this side I'll be writing it RABC. Okay. Now, tell me, if you write the RADC, you'll be writing this now, rho LADC upon area of this particular section, and then RABC is rho into LABC upon the same area. Agree? Yes or no?
Yes, sir.
Right? So don't you find length of ADC section equals to length of ABC section?
Yes, sir.
Right? Now see here, length of ADC section is equals to length of ABC section. And resistivity, because we are using the same material, so resistivity will be same for both of them. Area of cross section same for both of them. So can we say that RADC is equals to RABC? Say yes or no?
Yes, sir. Yes, sir.
Right? So if resistances are same and the 2 points between which we have to flow the current, both the points are same for these particular length of conductor. So can't we say that IADC is equals to IABC?
Yes.
Say yes or no?
Yes.
Everyone? Any doubt?
No, sir.
Right. So if IABC is equals to IADC, we need to find the magnetic field. Magnetic field, we know that magnetic field B is mu naught I upon 2r. And you know, this is for a circle, na? This is for a circle, isn't it? This is for whole circle. So what will be the magnetic field for a particular semicircle at the center here? Can you tell me? Anybody? It's easy. Whatever is coming to your brain, just say that.
The mu naught
Is
I
it
by
right?
R.
Go on, go on, go on. Anybody of you? Kalpagesh, you're saying something?
Sir, mu naught I by R.
Mu naught
Mu naught I by R.
by r. Okay, Laya, you were saying something?
Sir, is it mu naught I by 4R?
Okay, Vaishnavi said that mu naught I by 4r. And that is correct. Kalpagesh, see here, if we are considering the whole circle, we are taking mu naught I by 2r. So if we are taking half of the circle, we'll multiply this with half, na?
Ah,
Isn't
yes,
it?
sir. Yes, sir.
I think you did that mistake. You take it conversely, right?
Yes,
You
sir.
must be thinking the
Yes, sir.
same thing. I know that. Good. Laya, you were thinking the same thing?
Yes, sir.
Good. So Vaishnavi answered it correctly. Good. It is mu naught I by 4r. And you know, you can use the method of unitary method to answer any of such questions. You'll be getting a questions like this now. We have this wire that is 1/4 of a circle. 1/4 of a circle, 90 degree, and this is the radius r. Okay. This is 1/4 of a circle. So can you tell that what is the magnetic field at this particular point? Center O. Tell me.
Mu naught I by 8R.
Good. Mu naught I by half of this, 8r. So to generalize this, I can write it as for 2 pi r angle. For whole circle, the angle is 2 pi r. You know that? You're preparing for JEE or NEET. Do you have biology or maths?
It's just board exams, sir. Not any of
Like
those.
you are having maths or biology?
Max and
Maths na.
yeah.
Every one of you will be having maths. So you will understand this for the whole circle. You have the angle 2 pi r. The angle 2 pi, sorry, angle 2 pi. Agree? So for 2 pi, our magnetic field becomes mu naught I by 2r. So for unit angle, if you want to calculate the magnetic field due to 1 degree angle at the center, this, if I make it straight, okay, like this something is there. This is making 1 degree angle. And this is the length where current is there. This is the radius. This is the center O. So for this 1 degree angle by unitary method, what will it be? Mu naught I by 2r into 1 by 2 pi. Everyone agree or not?
Yes, sir.
Yes, sir.
Yes, sir.
General unitary method. Now for theta angle, any random theta angle, so it will be mu naught I by 2r into theta upon 2 pi. Now you can put theta 180 degree, you'll get for semicircle. You put theta 90 degree, you'll get for quarter circle. You put theta is equals to 2 pi, you'll get for whole of the circle. You can write it down. Write it fast, then we'll be getting back to the question. Done? You can draw this diagram also. Theta, magnetic field at center O, and this is current I. This is radius r. Understood or not?
Yes, sir.
Okay. Written? Shall we move on to the question?
Yes, sir.
Okay. Now the question was saying that we need to calculate the current due to the semicircle. So you know what is the formula for semicircle? It is mu naught I by 4r. But see here, magnetic field at the center O due to the curvature of ABC. Okay, you will write mu naught I ABC upon 2 radius, and same magnetic field at the center O due to the curvature ADC. You will write mu naught I ADC upon twice of radius. Everyone agree or not? Agree or not? Yes or no?
Sir, can you explain again?
See, magnetic field at the center O due to this curvature. I shall change the color. Due to this curvature, this one. Magnetic field at the center O due to this curvature. Okay, ABC will be what? Mu naught into I, current that is flowing through ABC, divided by 2 into this radius. Isn't it?
Yeah, yes, sir.
And same thing you write for the right hand side. B, magnetic field at the center O due to this curvature.
Okay, sir. Okay, sir. Understood. Yes, sir.
It will be I ADC upon
ADC.
2R. But in both the cases, I ABC is equals to I ADC, and radius is same for both of them. So can we say B at the center, magnetic field at the center due to the left hand side curvature and the right hand side curvature will be same?
Yes, sir.
Right, everyone?
Yes, sir.
Laya, everyone, please answer this.
Yes, sir. Yes, sir.
Okay, but the thing that is important here is the direction. Can you tell me what will be the direction of magnetic field at the center due to the left hand side curvature, that is ABC? Is it inside or outside?
Outside.
Outside. Right. So I shall write it outside here. Oh, sorry. It is opposite now. This is for inside. This is outside. Now, what is the magnetic field direction at the center O due to the curvature of ADC?
Inside.
Inside. Everyone agree with this?
Sir.
Yes, sir.
Right. So what will happen if you have two magnetic fields? BADC is equals to BABC, isn't it? But with a negative sign it will be there because both of them are vectors. Agree?
Yes.
That means magnetic field at center due to circular part is equals to 0. That circle is not responsible for any kind of magnetic field at the center. Agree or not?
Yes.
Everyone?
Yes, sir.
So now the thing is there, the magnetic field will only be due to these two wires that are coming and going. This wire at this distance, this is the radius r. Okay, you have to take one angle. You know that formula, mu naught I by 2 pi r into sine theta 1 plus sine theta 2.
Yes, sir.
So there theta 1, here theta 1 will be 0 and theta 2 will be infinity because this is coming from infinity, right? And this will be, what will be the direction of magnetic field here due to this wire? This wire coming from P, and this is A, this is C, this is Q. So what is the direction of magnetic field at O due to this wire PA? Don't know? I'll give you a very small hint. See what you have to do. You take your right hand, okay, straight right hand, no curve. Then what you do, you place your right hand, the finger should point the direction of the current. If my current is going this way, I'll place the right hand along this direction, right? Point number 2 that you have to do, face your palm towards the point on which you have to calculate the magnetic field. So that is downwards. Are you getting my point?
Yes, sir.
and place your thumb perpendicular to the fingers. Your thumb will give you the direction of magnetic field. Place your fingers along the current, palm facing the point, thumb perpendicular. Tell me where the thumb is pointing. Where the thumb is pointing?
They're out of the plane.
Out of the plane. So for this particular magnetic field at center O due to AP is whatever the value is, that is out of the plane. And same thing at the center O due to CQ, where current is going this side. So to take the right hand, turn it this side, palm facing upwards because O point is upward. Then tell me where the thumb is facing, the thumb is pointing.
They're out of the plane.
Again out of the plane. Everyone agree with this?
Yes, sir.
Tell me. Everyone agree with this? Right?
Yes, sir.
Okay. And what is the magnetic field value? B due to the wire is, if we take any wire like this, and this is coming from infinity going towards infinity, and we want to find the magnetic field at this particular point, that is at a distance, perpendicular distance between the point and the wire is A. And we need to calculate for this particular length only, not for the whole infinity part. So let us say this is phi1 angle and this is phi2 angle. Okay. So magnetic field will be what? B will be mu naught I by 4 pi r sine of phi1 plus sine of phi2. You remember this?
Yes, sir.
So in this particular case, your phi1 will, because this is the perpendicular distance. So your phi1 is 0. You take this line here because this is starting from here. Our present condition is something like this. Your phi1 is 0 and phi2 is going towards infinity because that is touching the angle. If you draw an angle from here to meet this point, and this point is at infinity, so you'll have to draw the straight line, nearly straight line, na? Isn't it? For example, if I want to find for this particular length, so this will be my angle, this will be my angle. If I want to find this particular length that is increasing, so my angle will also be increasing. And if I'm taking one of the length at the infinity, so this line will be nearly perpendicular, isn't it? Here it will be nearly perpendicular. This is at infinity, isn't it?
Yes, sir.
Agree, everyone?
Yes,
so phi1 is what? 0. Phi2 is what? 90 degree. Phi1, the left hand side angle for this particular point is 0. Phi2 is 90 degree. Both of them has got the same values. Even this is carrying the same current. The lower part also carrying the same current. Same distance r. Same angles. So you can just multiply. So net magnetic field at center O will be nothing but twice of magnetic field due to the wire AP or the wire CQ. Isn't it? So try to solve this question after this class, and you'll get the answer as 2 into 10 to the power minus 5 Tesla. Write this answer and try to solve it. Do we have another class after an hour, I guess? Do we have another class today?
So it's for a different batch.
Okay, it will be a different batch then. So solve this. One more question I'm giving it to you. You take this for screenshot quickly. Have you written this one? This one you have written all the concepts here. I have given you the concepts or more than 2-3 questions in this particular question. For the circular one, you know what question you'll get? You'll get a question like this. What is happening? This is a circle, okay, and radius, let us say 5 centimeter is given. 5 ampere current is coming and 5 ampere is going from here. So what will happen? This 5 ampere coming, so it will get divided into this some part I1 here and some part I2 here, and then it will converge at this particular point and then go back. Isn't it? Agree, everyone?
Yes, sir.
So what you have to do? Okay, one more thing. This is pointing towards the center. This is pointing towards the center, and you have to calculate the magnetic field at the center. If you do this question, you understood all the concepts for the circular one. Try to solve this. and we'll discuss the things in the next class. Till here, you understood or not? That we discussed?
Yes, sir. Understood.
Everything?
Yes, sir.
Okay.
Sir, can we go to the previous slide for a minute?
This one or
When-
previous to this?
Yeah, sir.
Don't leave any concept. Try to understand everything.
So the slide before this.
Slide before this, yeah. This one?
Yes, sir.
Done, everyone? Everyone, is it done? Hmm? Take this screenshot quickly. We'll end the meeting. Taken?
Yes,
Done,
sir.
sir.
Okay. So hope you liked the session. You understood everything. Shall we end this session?
Yes.
Yes,
Okay,
sir.
very good. The good students, keep practicing. Don't leave practice. If you'll keep practicing, you'll get the complete concepts of physics. Good. Bye then.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.